Good day to you all. My name is Mikel and I'm a senior physics major attending an internship for astrophysics at the Florida Institute of Technology. All of my past experiences have shaped me to be the person I am today. But the opportunity and experience in coming down here to Florida Tech will shape where I proceed in my life from here on out. Since I've arrived in late May, I've had an enormous amount of time to think and ponder if this is the right path for me. I know now that this is exactly what I'm supposed to do to make the impact that I need to make on this world. To describe my experience is simple. It's a dream come true. I'm doing exactly what I wanted to do as a kid. Looking at stars has been my dream since as long as I can remember. To me, it is simply the best way to use my imagination because from the first moment to the last breath, I have to conceptualize every angle and image I encounter. At times it is very overwhelming, but honestly, I wouldn't want it if it were easy in any way. I love the thrill of every single challenge because in the midst of difficulty lies opportunity. Before I would shy away from big situations, but now I tie my shoes tight and head full force to the hurdle. This enterprise to me is indispensable to who I will become, and I have to thank everyone who made it possible. The Department of Homeland Security, Mrs. Stephanie Willett, my parents Stanley and Cynthia Tucker, Dr. Tim Akers, School of Computer, Mathematics, and Natural Sciences, my advisors Dr. Bashador and Dr. Wood, and the Florida Institute of Technology. I chose my project because it was the one project that others directly benefited from my work. This summer I've been fortunate enough to combine astrophysics with engineering as I have manufactured a camera mount and brace to fit a new CCD camera to take optics of the night sky. The Ortega telescope, located at the F.W. Olin Physical Sciences Center at Florida Tech, is the largest research quality telescope in Florida, and its capabilities are about to be enhanced to a degree you will soon find out. Currently attached to the 0.8 meter 32-inch telescope is the PL 4022 CCD camera. This camera was one of the top cameras used for astronomical imaging and X-ray applications. However, the new Icon-L 936 CCD camera is a state-of-the-art camera with bigger and better features. The Icon 936 will be able to take better, clearer pictures at a faster rate with a higher signal-to-noise ratio. It will have a wider field of view and higher resolution than the current camera. I immediately took action, coming up with the best possible solution for the problem. My responsibilities included drawing and building a mount and brace to hold the Icon CCD camera, installing the camera, and making sure that the camera is running properly and efficiently to begin taking beautiful optics of our wonderful galaxy and beyond. Although the Icon-L 936 is significantly heavier and longer than the PL 4022, the current mount almost fits onto the new camera. Only minor modifications need to be made for the mount to be sufficient to the new CCD camera, such as a slightly smaller diameter for the shutter and lens, put in closer screws to connect the camera to the telescope, and create a slimmer design for the actual mount because the amount of space is vital to the optics we hope to take. The mount will have a cylindrical shape around the shutter as to not let in excess light and overexpose the images. The main focus is to create a face mount that would attach to the telescope yet not be as bulky as the lens to detector plate that came with the camera. The construction of the mount will include a brace to account for the extra weight and length since the new camera is considerably larger than the current camera. I've constructed a brace for the Icon CCD camera that will consist of two pieces, both similar in design but having opposite interlocking pieces to accommodate the excess weight and length. If you look at the second slide in my presentation, you will see that the camera has cylindrical grooves that could be used to secure the device without hindering any functions that the camera is made to do. Both pieces will screw into the face of the camera, into the face of the mount, and engage at the top and bottom respectively at the back of the camera on opposite ends. This design, I think, will hold the camera in place without any possibility of slippage. The bars will run along the sides of the camera, will coincide with the cylindrical grooves at the four corners of the camera. This will allow for the maximum minimum effect, maximum support with the minimum amount of material used. It first started as a thought, of course, but then thoughts began to formulate. I drew schematics and downloaded AutoCAD to create a 3D model which assisted me in creating a tangible model out of balsa wood that Dr. Bachelor bought me. I got to see my ideas come to life, and I'll show you them now. This is a design that I made for the CCD camera and brace. It's a little longer than the actual design. And this is the finished product. As you can see, this is where the camera will be. And there are certain As you can see, it's not as crisp as a computer program, but it was enough combined with the AutoCAD design to give to the machine shop tech and make the finished product. Speaking of the camera, let's go over some of the specifications that separate the two cameras. Starting with the PL4022, the pixel size of the camera is 7.4 micrometers. The thermoelectric cooling device can get to a temperature of negative 55 degrees Celsius, and it has a quantum efficiency greater than 50%. The field of view is 21.4 millimeters by 21.4 millimeters. The read noise is 9 electrons root mean squared, and the well depth is 40,000 electrons. And the Icon-L 936 CCD camera, the pixel size on it is 13.5 micrometers. The thermoelectric, cooling device on this new camera gets to an extremely low temperature of negative 100 degrees Celsius. And it has an astounding quantum efficiency greater than 90%. The field of view is 27.6 millimeters by 27.6 millimeters. The read noise is 2.9 electrons root mean squared, and the well depth is 100,000 electrons. Plus, this camera has a frame rate slightly less than 1 per second. With all this talk of CCD, read noise, and well depth, allow me to go in depth a little more with that. CCDs work by converting photons into electrons, which are stored in each pixel. Each pixel can hold a maximum number of electrons, in this case 40,000 and 100,000 respectively, but typically from 35,000 to as many as 500,000, depending on the specific model of the CCD. While exposing an image, photons strike individual pixels and are converted to electrons and stored in each pixel well, or the well depth. The number of electrons stored in each pixel well is proportional to the number of photons that struck the pixel. The mount that I have created only needs to be 1.7 centimeters, but 2 centimeters should be sufficient space for the compartments that slightly extend past the camera face. This 2 centimeter face mount is much more efficient than the 4.65 centimeter lens to detector plate, which only about 2.5 centimeters of it is significant to the function of the camera. The rest is just bulk. The cylindrical lens ring only has to be 1.7 centimeters, as I mentioned earlier. This will directly latch onto the telescope, giving the camera more room to adjust for certain optics. The diameter of the inner cylinder is to be 5.2 centimeters. This will accommodate for the rubber ring located just inside the inner circle to block excess light. The thickness of the inner cylinder is to be about 4.5 millimeters, and the rubber ring is 2 millimeters. The outer cylinder is to be 10.3 centimeters as to account for the solenoid and hinge that will be opening up the shutter. The outer cylinder is to be 2 centimeters thick, the same depth as the mount. In creation of the mount, the machine shop used a specific kind of aluminum called T6061, which is very durable and heat resistant, so it won't become hot as the camera is in use for an extended amount of time. Next is to test the two cameras against each other and compare the results. I'm currently in the middle of reducing said data and should be finished with my report by the end of the week. I can't express how sincerely thankful I am for me to be given this opportunity. Once again, I would like to thank everyone involved for this opportunity and believing in me and changing my life in a way that you couldn't imagine. I promise you will hear about me in the future at the top of my field, giving back in the same way you have so graciously given to me. Thank you for your time and attention.